Put that there. Go away. All right, apparently I will close them. All right, so worksheet 17. Oh, I forgot to say this before I started the recording, but the summative next week will be include the retake on advanced graphing and writing an equation of a graph, okay? That's the one that started at the number 4 through 6, maybe, was that section, okay? Then it will include what we're doing today. It will include 2 sections on law of sines and cosines, which we really have already talked about. And then this is what we're going to do tomorrow, is this 4.4c trig modeling, tomorrow and Friday. And then Monday we will revisit law of sines, cosines, and Tuesday we'll review for the quiz. Thank you. So that we are all set for a quiz next week, Wednesday. I have the homework check being printed now so that I can probably pass it out tomorrow, okay? Any questions? All right, you already are supposed to have watched the video on tangent. I am just going to review this. I don't think you have this. This one is tangent, okay? You don't have tangent on your paper, okay? But you're supposed to have taken notes already on tangent on worksheet 16, but I don't think it included this exact. I just want to review the idea. Okay. The idea is when you have a unit circle and you start here, the ordered pair is over 1 up 0. So when you put y over x, 0 over 1 is what? 0, okay? As you continue around this way, the slope increases very quickly. That's really what you're talking about. That is a fairly flat line. This is a fairly steep line, right? Until you get to 90. When you get to 90, the ordered pair is 0, 1. When you put y over x there, what is 1 over 0? Undefined. So at pi over 2, this had an asymptote or an undefined place. The same is true at negative pi over 2. And it will be a true down here at 3 pi over 2, because if you're at the ordered pair 0, negative 1, when you put negative 1 over 0, you still get an undefined place. Now, because tangent, do you remember how it goes? Tangent is positive here and here. All students take calculus. That really has to do also with the fact that that line has the same slope in both quadrants, right? And this line has the same slope in both the quadrants here and here. So this graph of tangent repeats every pi over 2, not every pi. I'm sorry, repeats every pi, not every 2 pi, like a sine and cosine do. All right, so I just want to talk, if you were to have to graph this on your quiz, big nod, yes, you're going to have to graph this on your quiz, okay? Just like this, 2 periods, that's it. You would have to tell me that it had an x-intercept at 0, 0, and another one at pi 0. It does, the only y-intercept would be 0, 0. Okay, it has asymptotes at x equals negative pi over 2, positive pi over 2, and then this one would be 3 pi over 2. Okay, it has no amplitude because it is going up and down infinitely. The period is pi. I don't know why I need to rewrite that. I don't think I do. Okay, so hint, that question is on the quiz right there. It says graph 2 periods of the tangent. This is 2 complete periods. Does everybody see that? Even though it only goes less than 2 pi, it's 2 complete cycles. And you need to tell me where it crosses the x and where a couple of the asymptotes are. Okay? This is ideas that were on worksheet, is it 16 or 17? This is 17, isn't it? Is it worksheet 16 maybe? See worksheet 16? Is that where we did tangent graphing? Yes, okay. So if you wanted more ideas about that, it's 16. Okay. Today, cosecant is the reciprocal of sine. If you wanted to try to graph a cosecant graph in your calculator, you'd need to do 1 over sine. It's not helpful in your calculator because I am going to make you do exact values. But if what you would normally, if I told you to graph a cosecant, what you would do is graph a little sine graph. So let's see, this is 0, 0. Sine starts at 0, 0, right? And it goes up to 1, back to the midline, down to -1, back to the midline. So how fast can you throw a little sine graph on here? You actually shouldn't need me. You should all know how to graph the sine. Okay, how we doing? How long did it take to finish a cycle of the sine graph? 2 pi, yes? Okay. If there had been a b in here, it would be 2 pi over b. But what happens for cosecant is it is the reciprocal of that green graph. So what is the reciprocal of 0, guys? 1 over 0 is? So every place that this had an x-intercept, the reciprocal graph will have an asymptote. Can anybody tell me where those are at? X equals what? X equals 0, pi, 2 pi, negative pi, right? There's a fancy way of writing that, but I'm just going to write that for now. That's good enough. All right. Then let's talk about the value right here. The value of that is 1. What is the reciprocal of 1? 1 flipped over stays 1, yes? So this actually has a max or a min right there. And here we're going to keep the negative 1s as well. Okay, now I need you to think with me for a minute. Right here, I'm going to say the value was 1/5. What is the reciprocal of 1/5, guys? 5, right? Right here, the value was 1/2. What's the reciprocal of 1/2? 2. I'm just estimating, but the idea is that those really little tiny close to the x-axis points, when you do a reciprocal, will become really big. The negative values, if this was -1/2, it will become -2. If this over here was -1/10, it will become -10. So those little pieces just flip. So what you do, you graph the sine, you find all the places that that graph crossed the midline, and you put in an asymptote. And then you take all those little hills and valleys that you drew, and you flip them up or down. That's it. All right, the domain in fancy terms is all values except where x is a multiple of pi. So x cannot equal pi n. All values 0 pi, 1 pi, 2 pi, 3 pi is where it's undefined. The range, can anybody remember how we state range? From the bottom, it's everything until it gets up to what? Where did the red stop? -1, and then it picked up again where? +1 and up. That's just a good review idea. I'm not going to ask you that on a quiz. All right. Where did it cross the x? The red. Where did the red cross the graph? Never, right? Did it ever cross the y? No. Okay, it is actually said to have an amplitude. It would be if there was an a value out here, okay? I am never going to ask you about the amplitude of this graph. I didn't even know it had one until I studied the notes for today. If there was a horizontal shift, I'm not going to ask you that either. So there might be one that has a vertical shift, at least on your homework, and that would be plus or minus k on the back there, okay? The plus or minus h would be a horizontal shift, but I'm not going to ask you about that. I know I didn't assign any of that. It's possible I assigned one with a stretch, because if this said 2 cosecant, guys, anybody guess what you'd graph first? Instead of 2 cosecant, you would graph what in green? 2 sine. Okay, and then you'd flip it over, but we'll do a little practice. All right, I'm going to go a little quicker on this one because, well, we got to graph what first? Cosine. So that's going to start at the max of 1 and go down to 0, down to -1, 0, and back up to 1. And the same thing in the other direction. And again, everybody in here should be able to draw the most basic cosine graph. I know it's kind of weird on this graph paper, but okay. What I explained a minute ago, how do you figure out where the asymptotes are? Wherever that original graph did what? What values are undefined when you divide by 0? So every place that this had a 0, which was at pi over 2, and 3 pi over 2, and negative pi over 2, and negative 3 pi over 2. This will have asymptotes. Okay? So the undefined places are x cannot equal pi over 2n, where n is integers, 1 pi over 2, no, odd integers. I'm never going to ask you that, so don't freak out about that. All right, don't care. All right, what are you going to do with all these little, this is a hill right here, so what do we do with it? Well, the reciprocal of 1 is still 1, but the reciprocal of these little numbers gets really big. So you flip that over. What is this one going to do? Anybody know? Same thing, but pointing where? Down. All those negative values will just get more negative. Now, I always made students graph these in the past, and I'm going to make you do it on the homework, but on the quiz, I just gave you a graph, and you have to tell me it's a secant or a cosecant or a tangent or a cotangent. For 1 out of 4 guess, okay? I made it as easy as I could. All right, where is this? The range would still be from -infinity to -1, and then from 1 to infinity, same as on the last one. The x-intercepts, where's it crossing the x? Never, right? This one does cross the y, though. Where does it cross the y? Yeah. Did I do that right on? Oh, yeah, this, it was tangent had an x. I thought, did I put an x-intercept? That was for tangent. I got really confused myself. Okay, amplitude would be the absolute value of A, which we're not ever going to talk about. The period of this, how long until it is done? Guys, look over here. If I start here, right here, it has this branch, and then it has all of this, and it has this piece. Even though it's really wonky, do you see that the length from where I started at 0 until the length where it finishes, all of the little pieces is 2 pi, okay? Makes more sense to me to say, you know, it's here to here is 1 period or something, but the period is 2 pi. because it's the reciprocal of something that had a period of 2 pi. The only thing I might do a vertical stretch would be the a value, and anything up or down would be the k value. The period would be 2 pi over b if I was that mean as to change a period on a homework question. All right, one more to do. All right, I would suggest you don't do this, but I'm going to draw on here tangent real quick. I'll do it in yellow so it doesn't really mess us up too much. But this is the tangent graph from a minute ago. Okay. Okay, that's what the tangent graph looked like. Now, cotangent is the reciprocal of that. Well, what is the reciprocal of 0, guys? I've asked that question a couple times today. Reciprocal of 0 is undefined, right? So we're going to have an asymptote there. Where this had a 0, where the tangent had a 0, we're going to have an asymptote. Where the tangent had a 0, we're going to have an asymptote now. Now, what is the reciprocal of a really tiny little number? Like, let's say that green dot right there was 1/10. The reciprocal would be 10. So be up really high. Okay? The reciprocal here, this is at pi over 2. So let's just talk for a minute. The ordered pair at pi over 2 is over 0 up 1. Cotangent is x over y. What is 0 over 1? 0 over 1 is 0. So cotangent looks like this. Okay? Cotangent, this is the way I think of it. This is a positive x cubed. Do you remember that ever from doing those last fall? Remember, right hand up is a positive x cubed. That's the tangent shape, okay? It's not officially a tangent shape because an x cubed keeps getting wider and wider infinitely, and a tangent shape actually has asymptotes. But the cotangent shape would be the flip of that, but it also shifts over. All right. The domain is on x cannot equal, where was this had asymptotes? At 0, pi, 2 pi, right? I'm just going to write that. Okay, it has asymptotes at 1 pi, 2 pi, 3 pi, negative pi, etc. The range here is all real numbers because bottom to top, it does go up and down forever. The green one crossed at what x values, guys? Anybody know where that one? Yep, that one is a pi over 2. It would also have one at negative pi over 2. It would have one at 3 pi over 2, etc. It does not have a y-intercept. And the period is pi, not 2 pi. And it doesn't have an amplitude. And I'm going to call it good enough. All right, I was hoping to make this video about 20 minutes. Let's see if we can get it under 25. How's that? All right, I am going to go to, is this the back of that page? Number 1. Why do I want to do number 1? Ugh. All right, I'll do number 1. What you would graph here is actually 1/2 times what? What's the reciprocal of secant, guys? Cosine. Okay, so in dotted line, I'm going to graph a cosine graph. whose amplitude is only 1/2. Its period is 2 pi. Cosine starts at the max. Min would be at pi. Intercepts here. I don't like that it has such a little amplitude, but that's what it would look like. Can you slap that on there? All right. Where is the secant graph, which I'm now going to do in blue? Going to have asymptotes. Somebody give me an equation of one asymptote. Where did the graph we just drew cross the x-axis? At x equals pi over 2. Where's another one? X equals 3 pi over 2. I'm going to call that enough. And in a minute, I'm going to make you write ordered pairs. But for now, let's just draw in those asymptotes. I'm going to draw more than that, but I'm only going to list 2. Okay, remember wherever it had a 0, when you flip it upside down, it becomes undefined. All right, and then all these little bumps are going to flip around. They stay where they were, okay? This one was at pi negative 1/2, so when you flip it over, it's still at pi negative 1/2. It's just that the values on either side of it become more negative or more positive. All right, that looks like enough graph for me. Give me 2 ordered pairs. Can anybody tell me 2 ordered pairs? What was this one right here? 0 what? 0 1/2, and this one down here was pi negative 1/2. Is everybody okay with that? Over pi down 1/2. Mine looks like it's at -1, but it's not supposed to be. Okay, good enough. Anybody need more time? All right, we are going to graph, oh, this one's got a period change. We are going to graph like the flip of cosecant is sine. Okay, what can you tell me about that sine graph? It has a period of 2 pi over 2 or pi. So we need a sine graph that starts midline, up to 1, back to midline, down to -1, midline. Okay, so that's the sine graph. So what would the cosecant look like? It's not that complicated, guys. Where this had a 0, like at 0, it's going to have what instead? Okay, so x equals 0 is an asymptote. Can somebody tell me an equation for another place? Where's another place it was crossing? X equals pi over 2 and x equals pi. Would that be a couple of them? Because the amplitude, the period was 2, there's a b value of 2. I mean, it shrunk the period down, and it happens more often. All right, so the actual graph would be this. And this one gets flipped around. And this would get flipped around. And it would have had another asymptote here at 3 pi. Okay, so just give me 2 ordered pairs. Somebody? 1 ordered pair? Anybody? What's this one right here? Big purple dot at pi over 4 and 1. And this one down here is at, there we go. You have to do this on your homework. But like I said, on the quiz, it's just like tell me which graph it is. That's it. All right. I don't care if you don't write this one down. You would shift this up to, because of the +2 here, okay? This is a vertical shift. The cosine graph, does not go through 0, 0. It has an asymptote here. And it has a period of pi. So it has another asymptote at pi. So at pi over 2 is where it crosses that line. And which way does cotangent go? Do you remember? Tangent goes this way. And cotangent goes this way, right? Yes, cotangent, oops, where am I at? Cotangent, do you see it starts at the top and goes down? So that's what we're going to do on this guy. We're going to shift it up to, or start at the top and go down. I'm just going to draw that and be done. It has an ordered pair at pi over 2 and up 2. And it has as asymptotes x equals 0 and x equals pi. I hope I only have one left. Oh, I have 2, but I'm only going to do this one. Number 7, what would you draw? What would you draw, guys, to start this one? Number 7. Is this on the same worksheet, or is... Oh, this is the worksheet some of you don't have. Worksheet 18, somebody said they didn't have. All right, just don't worry about it if you don't have this worksheet or you don't want to write this one down. But you would graph 2 cosine 1/2 theta. Talk me through it and I'll shut up for the day. What is the amplitude of our cosine graph? 2. Cosine starts at the max, right? Okay, b is 1/2. So 2 pi divided by 1/2 becomes 4 pi. So it's going to finish by 4 pi. Okay, it would be down at -2. Okay, there's our cosine graph. Let's see, it would cross again at 5 pi and minimum at 6 pi. Okay, what do we do to that? To change it into a 2 secant theta over 2, or 1/2 theta. Where it was crossing the x, I'm going to put what? An asymptote at x equals pi. Where's the next asymptote? 3 pi and 5 pi? And what am I going to do to all those little u's in between there? Flip them the other way, yes? So that ordered pair would be 0, 2. Right down here, there would be an ordered pair of what? Give me that one and I'll be done. 2 pi -2. Okay? All right. So what you're supposed to do today is to, on worksheet 17, go back and do numbers 2, 4, and 6. 2, 4, and 6. And then there's a delta math called reciprocal trig graphing. The estimated time according to delta math is less than 10 minutes to get that little assignment done, okay? I will tell you, a bunch of them are matching. Like, what is the equation of this graph? And it's literally secant, cosecant. It's not like 5 cosecant 7x, okay? It's literally, is this a cosecant? Is this a secant? Is this a tangent? Is this a cotangent? Those you don't get multiple questions, okay? If you get it wrong, it's just wrong. You can't make it up because it literally, I asked one of each. So use your notes so you get those right. All right, I done.